to our experts. This webinar is GRAITEC Group Intelligence. My name is Missy Scott, and I am pleased you can find a schedule of upcoming events, webinars, and training on our calendar at .com/calendar. Very pleased to introduce you today. Nehama is the Chief Operating Officer of Arch Intelligence. Emily is a technical consultant at GRAITEC, and we also have Oded, who is a product expert at Arch Intelligence. He will help field questions in the live chat and Q&A. Thank you all for joining us. And before we get started, I go through a little bit about what office hours is and how it's different. This is a free platform for you guys to ask questions and get live answers. We'll kick things off with a quick tip and then drive straight into open discussion. I do love making office hours fun, so there is a little incentive. Anyone who asks a question will receive a Starbucks gift card on us. Since we've got a super big crowd, I do want to have some rules for fun today. It's a really big group, and we all want to enjoy the experience. So please post your question one at a time, either in the Q&A, which is what we recommend. It is easier to follow and to answer, or in the live chat. You must ask a question to receive a gift card. Questions must be asked during the live session. And I'm your only moderator. There's only one and only Misty, so nobody else please moderate. I'm here for you guys. And then we do have our experts, Oded, Nehama, and Emily here for you. And absolutely be respectful of everyone attending and be nice, you guys. We're here to have some fun and learn some stuff. So some frequently asked questions. If your question is not answered today, we will be posting after the webinar. You will get recorded within 24 hours. You can reach out to myself. If you don't get it, I'm going to throw my email in the chat. You will get a gift card within 48 hours. It will take me a little time to process, so give me a couple days on it. And if you have any technical difficulties during the webinar, please make sure you're using Chrome, not Explorer or Firefox. Try to refresh your browser. And then if you still have issues, we do have a live support online with us. You can email them at support@hublot.com. They'll answer immediately. I'm going to throw that in the chat as well. All right, lots of stuff. I know you're here for the good stuff here. So I'm going to turn it on over to you ladies and gentlemen, and we'll get things rolling.
All right. Hi, everyone. A lot of people showing up today, so it's great to see everyone, and I really hope I'll be able to answer all your questions. And what we thought we can do before we dive into the questions themselves is give you an overview of what we talked about last time, and in generally, what are topographies in Revit, and why are we talking about them in the context of Environment for Revit, which is a plugin that, again, for those of you who weren't here last time, Environment is a plugin that allows this really accurate and flexible site design in Revit. So without further ado, what I thought I'll do is I'll share my screen with you guys. Let me just move that one over here. And as I share my screen, we'll go over what we talked about yesterday. So essentially, you know, I saw in the polls that a lot of you guys are not using Revit. So topographies in Revit, instead of these contour lines that we used to see in AutoCAD, topographies in Revit are all made out of points. And when we're working with Environment for Revit, we found this really efficient way of working with topographies, and we call it the reference surface. So essentially, the reference surface is like theoretical surface that represents the grading and the slopes of an entire area. Just like this parking lot can be graded with just 4 points, but then every part of it could just align to this grading, right? And I gave a really good example, like imagine a roof, right? Where you have a roof and then you just define the slope of a roof, but then every shingle on the roof conforms to the same slope. You don't have to define it over and over again. And that's what we're doing in Revit to create a very efficient modeling process. Just like in this example over here, I already have the grading of the building pad. And then as my design gets more details, right, I add the more details to it, but I don't have to redo the grading of every area. Yet I still have a 3D model. So these Revit topographies and this method of working is really helping me both in the design process, but also in the modeling process as well. So for example, if we take really complex surfaces like this one, I don't have to calculate the elevation points for each part over here. I could just create a reference surface with 4 points and then have everything conform to it, right? So that's some of the things that we talked about last time where we had, very complex topics in topographies. And I actually prepared like a really fast example of how we can work with topographies with the toolset that really makes, this topography and grading very flexible. Now, I saw a lot of people asking in the Q&A, can we import these topography data from other software? The answer is yes. We can import that from Rhino, from AutoCAD, from Civil 3D, and use it and continue to design with it in Revit. In this example, I'm actually showing you how I'm designing a topography from AutoCAD using environment tools. So you can see how originally this topography was created with contour lines, but now with environment for Revit, I just added points on this AutoCAD surface. So then once I have this 3D topography, I'm in Revit, so I have so much information that I can extract from it. I can extract the volume. I can create a proposed topography that will later allow me to understand the cut and fill values of everything. So essentially, you can see an example over here of how, like in 2 minutes, I took an AutoCAD survey and I just modeled my entire site. When my site is 3D modeled in BIM, I have so much information I can extract from that, right? The amount of trees, the volume of the land. And then over here, you can see an example of how I can take my own design and start to design on top of this 3D survey. So I'm designing a 3D path connecting these 2 streets, right? And I'm doing it really easily with one of Environment's tools that's called an alignment. And this alignment is 3-dimensional. And because it's 3-dimensional, I didn't have to calculate anything. I just created a path, right? And now I can just take the existing topography and confirm it to the new path. And I can show it another workflow like that of how easy it is for me to just get my design on top of the existing data. Now that's on a very small topography, but it can be done on larger scales as well. And then each and every part of this model can provide the information of the cut and fill calculation for this part. So we talked about the reference surface. We talked about the amount of tools that we have in environment for Revit that could give you all the flexibility of the design. And that's the tool set. Basically today we have over 70 tools that are built in naturally into Revit that allows you very flexible design. We have tools for planting as well, but we're going to talk today about topography in general. Amy, do you have any interesting questions on the chat over there?
Hi, I have lots. And I just wanted to say I put it in the chat, but yes, we will be trying to answer all questions after the fact and send it out with a recording a few days from now. But give us some time. There are lots of questions. So, some of them are disappearing on me as I'm looking at them. So there was one there that I saw about, it was topography. So related to structures like tunnels, can we handle underground elements? Is that too much for now?
No, it's actually a really nice question. Let me create a fast example. So in Revit 2024, Autodesk introduced the element that is called the toposolid. And essentially, it's a solid topography. So let me just create a square shape topography very, very quickly to give you an example of why do we care about the fact that it's solid, right? What does it give us? So let's take a type, right? We have a lot of types of topography that we can define. We can define the layers, whatever. So let's just take the gardening and soil. That's a very basic topography that I have over here. And the reason I care that it is three-dimensional, let's really quickly use environment modified topography to really quickly kind of inflate this surface. So the example would be nice. Let's see the preview. Yeah, so I'm going to create this mound over here, right? All right. And we want to talk about tunnels, right? Yeah. So let's do something like that. And let's use a different type of topography. Let's use the variable material. All right, so why do we care that this toposolid that Autodesk introduced is a solid element? Because a solid element has layers. And then these layers have a volume. So if I click on this toposolid, you can see that I have all this information over here, right? The volume, the area, the parameter, whatever. And so as long as I have this volume, I can cut into it with a void element or something like that. So, wow, that's going to be a scary test to just really quickly create the sweep, I think, right? So let's sketch a path. Let's do something like that. And then let's give it a profile. Let's create a profile. Let's do something like that. All right. And then let's turn this one into a void element and have it cut this one off. But it's under that, right? So how could it cut it? So let's lift it up. All right. One second. I'm going to lift this one up a little bit. Right? And then have it being a void element, and you can see how it can cut into the topography, right? Just like that. Oh my God, that was a scary one to do live, right? Right. So that's the concept of how you can do tunnels in Revit, and then I can actually get the calculation of the cut and fill of this element specifically in Revit 2025. This entire topic got a lot more sophisticated, and you can definitely read more about it on our website. And we did a live webinar also with Beam Pure about that. So arcintelligence.com, just go to our news section, and you can see some information about Revit 2025 and how you can, how it can be, how it can work with this void and cutting elements. So yeah, that's a very cool feature that we have added in Revit 2024 and 2025. All right. I hope this answers the question.
Oded, do you have something interesting?
Yeah, there are a few questions regarding analysis, slope analysis, and height analysis, and I think Environment for Revit have great tools to address exactly this issue.
Yeah. So I think that's maybe one of the, I wouldn't say one of the first features, but it's pretty old by now. I'm going to open a file to demonstrate it, but just in the meantime, until I'm opening it, there's also something in our website in the homepage where we're like it's a whole video where we explain how to do elevation and slope analysis with environment for Revit, and it's actually one of the very old features that we have up here. Let's take a look at. Yeah, if you can take a look at our full tool set, so you can see there is a lot of drop downs, right? So if we take a look at the full tool set that we have over here, we have the elevation and slope analysis, which allows you not only to visualize the analysis of the slope and elevation, but also to get real information about it. So for example, here's this file opened up. Show you like existing site survey, right? So here's my slope analysis over here, and then I can see real information about it. You can see how much of my area has a good slope and how much has a bad slope. So for example, I know that that's the amount of square meters, right, with a slope that's going to be really expensive to develop. But then I know that the rest of my area has a slope that's really, it's not steep slope, so it's easy for me to develop. So this kind of analysis on this 3D, on this 3D topography is really useful at the first stages of the design process, right? So that's the original topography. Of course, it's a CAD survey that we imported to Revit, and then we perform the analysis on top of it. Yeah. All right. What else?
All right. I might have one. Sorry, it might be another scary one to do live, but it talks about how to model some complex landforms, such as like cliffs or terraced landscapes.
How to model complex topographies?
Yeah, so I know we have a terracing tool in Environment for Revit. Right. Cliffs, however, may be a little beyond what we can talk about today, but I thought this might be a good time to talk about something like terraced landscapes, maybe.
Yeah, that could be interesting. So I have to think about a good example, but generally speaking, there are two types of elements. Really, when we're talking about cliffs, that's when I would like to have the survey, right, of something that is original. And if I'm talking about a section, usually a cliff doesn't look like that. It's not like 90 degrees and 90 degrees, right? So usually a natural cliff would look something like that, right? And if you would want to do that in Revit, my best suggestion to you would be to do it with a point cloud. And then with Environment for Revit, we have this really amazing tool that where the algorithm can kind of automatically identify what is a topography and what is a different element, like a tree or something like that. And I can show you a really cool example of, well, it's not really a cliff, but it's a river that one of our clients used it. Let me see. I think it's this one. Yeah, right. So over here we had like a point cloud survey of a river, and like with environment feature, we could very easily create the topography of it. And you can see that it has like, the sides of the river, they really vary, right? So because topographies are from points, as long as you don't have a wall as long as you don't have a 90-degree situation, it's very easy to model. And actually with environment, you could do it in 2 clicks, right? It's one to model that. And then if you're designing a terraced landscape, that would be something else. So now let's think about how would you build something like that, right? You would probably build it like you have the ground, right, with grass or something, and then you have a wall, right? And then you have the ground again. And that's exactly how I would model that. That's exactly how I would model something like that, right? I would just create a topography. So let's create a topography that is, I don't know, has like a normal slope, right? Let's do like 1%. Don't worry if you're working on an imperial system, you can change the units. It doesn't really matter. So I have this topography, right? It has a slope that I'm happy with. And then what I would do, I would just create a wall, right? So let's go ahead and create a wall over here. Sorry. And make sure that this wall is in a correct elevation. There are many ways of doing it. With environment, you also have like many automated ways to do it. And then I would just create the other part of the terrace, right? So let's do something like that. Let's do 1 point over here, 1 point over here. Go to top view. And you can see how I'm placing the points. And I'm not really calculating anything. But still, I'm getting the correct slopes that I'm going to need to use. And I'm getting all the contour lines that I need in order to document everything in my model. So everything you see here, that's why we love Revit so much. It's because it's good for documentation. So now just imagine how easy it was for me to, let's even create, I think a structural foundation over here. So look how easy it was for me to create this terraced landscape, and it's ready for documentation, right? It's all ready to be sectioned and showed live. So yeah, that's my complex answer to that one.
I have another one that been repeating a few times. Somebody asked about cut and fill and also construction phases regarding earthwork.
Yeah. So I think that, so first of all, it's a very good question. Yeah. One of my favorite features when I started to work in Revit as a landscape architect is that it's not only 3-dimensional, I look at it as 4-dimensional, right? Because we always in Revit have the dimension of time. So essentially, I have like 2 different models that coexist and integrate. And that's the existing phase and the new construction phase. And then you can have as many phases as you need, right, in your model. So let's go over here. And that's where I have the existing phase. I have existing trees. I have the existing ground. And everything can be calculated. And then right above it, I have this model, right? So essentially, if I have a toposolid, I can calculate the amount of cut and fill, an amount of earthwork that I have for this part over here, as long as I have an existing surface and a new surface. Now, I think that in this one, I should definitely upgrade that into a toposolid. So I'm going to use environment topography tools to just switch the toposurface toposolid tools. And I'm going to make sure that it's defined as existing and demolished in the new construction phase. And then I'm just going to take one of the toposolids over here. And you can see that I have the cut and fill data. And there's also an environment feature that can really help me to get a more accurate analysis on this area. So essentially, as long as I have 2 overlapping topographies that overlap one another, that's just going to be a very easy schedule. And I think I have another example in this project that I opened here, that this project is a little bit more done, but in this grading plan that I have over here. So again, I have an existing topography and a new topography. And then when I model everything correctly in my phases, in 2 clicks, I could just create this cut and fill schedule, which will also automatically update if anything changes in my model. So as long as I have existing and new construction living in the same model, modeled correctly, each and every piece of my model gives me this information, and just in 2 clicks, I can get it into a schedule in the very first stages of my design and modeling process. Sorry, I have a little cold today. So I don't know if you guys notice.
That's okay. I hope you feel better soon.
Yeah, as long as summer is over. Just kidding.
Emily, do you have something?
Well, I've seen a few. Another one that's sort of ongoing is compatibility with other other softwares, right? So import and export, some sort of we know we can answer some of them, and then just to sorry, I'm babbling. Just to confirm with everybody, there's a lot of import and export. And I lost my train of thought. I'm just going to turn this over to you, Nehama. I ran that one under the ground.
Maybe specifically with AutoCAD, because you briefly talked about how bringing in topography from AutoCAD, and I think a lot of landscape architects are struggling with this because they already have their survey in AutoCAD and they're bumped to remodel it again in Revit. So maybe that, and also XML from Civil 3D data. That would be great.
Yeah. So generally speaking, Autodesk Revit is a pretty collaborative software by nature. But just like any other topic, in collaboration as well, Environment for Revit swoops in whenever there's a gap and just solves it for you. So in this video we saw at the beginning, you saw that I literally took a CAD survey and turned it into a Revit tool in a few minutes. And so using environment features, I could turn these blocks into Revit families, which are schedulable. I could turn these CAD contour lines into a Revit topography. And then using Revit regular export features, I could just export that back into AutoCAD. But then there are things that are a little bit more complicated than getting the blocks from CAD into families and stuff like that. For example, if I'm using the external civil data, let's go over here. So basically, if you're working with a civil engineer that provides your topographical data, in some cases it can be the survey. For other landscape architects, the engineers are responsible for the grading and levels. So all they have to do is to export their surfaces into a LandXML file format, and then I can use it to create my topographies, right? So let's go to external civil data and import, for example, the finished grade for the design that I have over here. And you can see it was like 2 clicks. I was able to import a topography. And as I click on this topography, you can see that I'm able to use environment topography tools to edit this topography and take a look at it. And I could just edit that, right? I have points, I can delete them, I can move them, I can change them, I can do whatever I want. So as long as I have this Civil 3D surface in Revit, this could potentially become my reference surface for other elements that I'm designing. So as long as I'm touching it with Environment for Revit, it's potentially a reference surface, right? So let's take these topographies That's my flat layout. So let's say I'm the landscape architect and that's, my design, but the engineer did the grading, which sometimes happen, right? And then I can take the match reference surface feature and just select this topography that I just imported in like 2 seconds and just have my topo solids confirm and adjust to the grading design from the civil engineer. And then I can take these ones, which are paving, and I'll do the same, but this time I'm going to give them an offset because I want like my paving to be a little bit above my original topographies over here, right? So I'm using the match reference surface feature and I'm just confirming all these topographies together. Let's turn this one off. I don't need it anymore. Of course, I can reload it. I can update as I go. And then let's talk about what is this reference surface, right? That I created from Civil 3D. So if I isolate this part, let's go. You can see that it looks kind of weird. And we're like, why is that, right? It was supposed to be flat. So if I'm going to turn on topography tools, you're going to see the original surface. That's the original surface from the civil engineer, and that's my boundary that I designed. And the combination of two of them is giving me this design, right? So why do they have a problem? Well, in Civil 3D, they did not come to my webinar and they did not understand that they should have one topography and then a wall and then another topography, right? They just try to create a wall using a topography, and that's very common practice in Civil 3D. However, it's going to cost us a lot of problems. So I could just go in and like manually correct everything over here, click on finish. And because I always have access to my reference surface, I can always adjust it and then go over here to export to LandXML. And then select my adjusted surfaces and send them back to Civil 3D, they will fall exactly where the civil engineer needs them and wants them. Sorry, my computer is a little bit tired, but essentially you have the import and the export features all available to you within Environment for Revit tools. So you can make adjustments, you can import that, you can use it as a reference for your grading. You can even import entire streets or corridors or roads from Civil 3D. And the same thing you could do with Rhino. If my computer decides to get back to itself, I can even show you the Rhino example on how to import topographies from Rhino. Yeah, I'm going to stop sharing for just like 2 minutes. Maybe it will make things easier for my computer. Right.
I'm just going to pop in here while we get that sorted out with a couple of more Revit specific questions that aren't so much to do with environment for Revit. And I know there's a lot of you out there who have not yet thoroughly seen Revit and understand, how it can benefit. And so there's a few questions out there, about visualization of 3D, a topo in 3D and creating those views and sections. And so a lot of these tools are built into the Revit software. Without environment for Revit, you can cut a section, a live section, through any part of your building or topo surface or topography. And although we cannot model everything to the nth degree, there are then tools to cut that section through what we have modeled and then add elements that we may not have modeled. So if you've modeled the foundation and the footings and the surface around it, but we need to add a weeping tile or we need to add gravel around that weeping tile, these are 2D elements that we can be added on top of any given surface. So, and same with 3D. Once you have modeled something, you may be looking at it in plan, but within Revit, you can see Nehama navigating around, and very quickly we can jump into an already existing 3D surface. So the line between 3D and 2D in Revit is sort of blurred because we are modeling in both at the same time. Even though you may be thinking about it in plan and drawing a wall in plan, it always has a height, and we can always cut a section through it without a lot of effort. So that's just to cover that one. A few of them, lots of questions like that. So
another question that repeats a lot, if there are some tips of dealing with large fields or large sites
yep.
And complex topographies. You're on mute.
Small pieces. Nehama's on mute, so the first thing I'll say is small pieces, and I'll let Nehama take that over.
Yeah, I realize I'm muted. So I want to talk about what Emily just said. And yes, in Revit, we're working on a 3D model, but we have a lot of ways to look at this model. And essentially, that's how we document everything, right? If I want to have a grading plan, I just look at my model from above and make it black and white, right? Or something, or just add some more information. But essentially, everything revolves around my model. I could just cut it, just like Emily said, and add some 2D details into it. So it's very efficient in this way. And now let's talk about what the question you brought up about dealing with very complex sites. So essentially, I do not think that Revit is here to replace Civil 3D. And if you're designing a new city in terms of roads, maybe Civil 3D is the right software for you. But to get to a detailed design phase and a construction design where you can actually build something, that's where Revit swoops in. And we have seen a lot of success with very large model. So officially, the Revit limit is 20 miles from end to end, and you usually don't get to such a big project. And then how do you deal with such big topographies? Well, that's very easy. You divide them. You model them one by one according to their function, material, slope, whatever you want to do with them, just like what I did over here. And then when you're working like that, the grading logics, everything makes sense, right? So instead of trying to build a very big topography like the civil engineer did in Civil 3D, I could just start by building this plaza, and that's it. So I know my elevation over here, and I know that it should slope over here. So it's very easy to build. And then the next thing I want to build is this path over here, right? And that's very easy to build as well, because in environment, I have the from edge tool and the slope tool. So I could just touch this edge and slope over here. So I have a path, etc., etc. So that's how I build my models. And with this method, we've seen a lot of success with a lot of architecture and landscape architecture companies all over the world, actually, building very complex and very beautiful models in Revit. Yeah. Any other question?
I think somebody noticed that your floor plan looks really nice and the textures are all aligned, and everybody's aware of the issue Revit has with the demonstrating the textures of sloped floors. Somebody asked if Revit fixed it. The quick answer is no, but
no, but Environment for Revit has a fix until they do. So essentially, first of all, for those of you who don't really know the issue, I could just really quickly show you what the issue is about. Let's go to the floor over here and show the pattern on the floor. And you can see that the patterns in Revit get twisted when you have a lot of elevations, when you have shape edited floors. So let's go back to the floor feature. And what I do, I just turn it off, right? So in this case, I'm just going to Control Z. So essentially with environment for Revit, we have a feature over here that's called object outline. That's the small one up here. And what this tool does, it just automatically creates a filled region that covers the entire floor, topography, toposolid, whatever. And it's creating a new filled region type with exactly the same definitions as the floor or toposolid type. And it will update with it if I change or modify the floor, if I modify the boundary, if I modify the type, if I modify the material. Anything that I will do with my floor, it would actually update automatically. So it's kind of a view-specific solution, but then again, it's a one-click solution. So it can give you a very good result working with patterns and creating beautiful material plans in Revit.
Perfect, thank you. And I think you mentioned to deal with large projects, it's a good idea to use links. And somebody asked how to align linked models in Revit. I think the question is about the geolocation, in a matter that if there's a few professionals working on the same project, how do you make sure that all of them aligned?
Yeah, so Revit is really great with collaboration. You can take a look again in this project over here. The architectural model is not a live model over here. It's a linked model by the architect. And you can link as many models as you want as long as you're geolocated and within shared coordinates. Environment for Revit really improved that area as well and made collaboration better. Of course, I think, Emily, you know a little bit more about this than I do, but with Autodesk, you have this very powerful cloud environment where you can collaborate with so many disciplines, right? I have projects where they used MEPs to do the sewer and water systems in the streets, and then road engineers from Civil 3D and architects building the building. So let me show you, I think, an example over here of very, very big projects. So both the cloud environment within Autodesk, the Autodesk ecosystem, and yeah, I think that's an example of one project that was all done in Revit, where you can see that that's one architect, that's a second architect, that's the road engineer, that's the landscape architect, and all of them are working together in this beautiful ecosystem where everyone can see everyone's changes live. So that's, just why Revit is so great and why environment, why we chose to develop a tool specifically for Revit because of its powerful collaboration options. Now, again, going back to our website, if you want to learn a little bit about the geolocation in Revit, in our news section, we have invested a lot of times to kind of break down the topic of how this collaboration works for, if you're really nerding out about it and you want to thoroughly understand how Revit collaborates, then this one is a really good article for you to read and to understand how to use the environment set coordinates tool to get a better coordination over here. Emily and Odette, I think my question is, are there any very interesting questions? Because if not, I'm kind of eager to show the alignment tool, I think.
I have a question related to that. So somebody did ask about modeling complex road alignments on a sloped site. So there we go.
Perfect.
That's for Aidan Morgan.
It sounds like I paid this person to ask this specific question.
Right? And I just happened to paste it into my little Word document over here.
All right. So, yeah, I think for me, it's very exciting because I've been waiting for this tool for quite a while now. So those of you who are a little bit doing civil engineering knows what an alignment is, and other people don't really know what an alignment is, but it's very easy to understand. Basically, an alignment is an object used to describe the center line of a linear object, right? In our case, a pathway, a road, or anything. So just imagine if I have a 3-dimensional center line over here, that would be the alignment. So easy. It's just that we're in Revit, so everything is going to be 3-dimensional, right? And then we were working for a very long time to develop a tool that will make path and road design in Revit as easy as it should be. And we finally have this tool, the alignment tool by Environment for Revit. We still have a few more steps that we want to achieve with that. But already right now, I think it saved me around 80% of the time that it took me to design a path in Revit. So let's just quickly create a road that connects this part and this part. And you know what? Before I start, I'm going to move to a plan view of this one. So it's just like I'm looking at my site from the sky, right? This is my site, plan view, 3D view, right? The same model. And I'm in Revit, so it's very easy for me to know what's the elevation of this area over here and what is the elevation of this point over here, right? And that's just plain Revit. That's why it's great, because it's 3D. We have all the information. So now let's create a new alignment. And the first step is not 3-dimensional. The first step is actually 2-dimensional. I'm just going to go ahead and kind of really quickly sketch how my path should look like. And I don't really care if I'm too accurate or not, because again, this is Revit. The name came from the word revise it. So I can just do something and adjust it later and make it, better later. But let's say that's like the overall path that I have. I have undo and redo buttons here, right? I can just do them. But that's the overall path that I have. If we go to a 3D view, you can see that it's pretty much flat, right? And then it has all kinds of parts like points and lines. And what I can do to start, I could just take the first point over here and give it an elevation. So I know that that's the elevation that I have at the start. And that's the last point that I have. So it's going to be 70, 73, 74. And again, I just adjusted the first and last points of my alignment. You can see that everything else is still flat. But then if I click on escape, I get this wonderful option. Again, if you're not a landscape architecture student, I'm not sure if you know what interpolation is, but it's just basically turning everything into a unified slope from start to end, right? So I'm going to click on interpolate, and it's just going to jump to be a unified slope. And as I click on any part of any segment, I can get the information of what the slope is. And again, if you're working with other units like 1-to ratio or something like that, that's what you're going to see over here. That for me, I'm just working with percentage, right? Then I can just manually adjust my path the way I want it to look like. So as I adjust it, I don't know if you guys ever designed a path, but it requires so much calculation of length divided by height equals percentage, right? I don't have to do that. I could just click on interpolate and see the resulting slope, right? And then I can even do something different. I can say, I want the slope here to be maybe -1%. And then I want to interpolate everything else over here, right? Let's filter that, take only the segments, and then go ahead and interpolate only the segments. So then I have like negative 2% slope, which is great. That's the result I was hoping for. And then a different slope over here. And then here I have like this crazy slope. Let's change it to negative 3% or something like that, right? And then negative 5. So I can really be very, very flexible with how I'm working here. And then, all right, let's say that I'm great with my alignment. But what's the next step? How do you take this 2D line and turn it into something that is actually a path? Well, I'm going to click on Escape, go to the cross-section option, and just place a cross-section here. And I'm going to do it really quickly. And you can find in our website like a more detailed explanation of all the things that you could possibly do with that. Let's click on Rebuild and see our path. All right, so then we have the preview of our path, and using environment tools, we can very quickly extract a topography from this path. All right, that's it. So it's a little bit under my existing topography. That's what the civil engineer designed, and I'm the landscape architect, and I'm like, no, listen, let's go to topography tools by environment for Revit and kind of adjust this topography to the path that I just designed. So I'm going to take the from edge tool, maybe with a 10 centimeters offset, right? And just have this topography align with this path over here. Oops. Sorry, I'm not really touching the correct edge. I have some, you see I touched a bad edge over here. That's it. All right, so we see all the blue points. Let me add them to my original topography and click on Finish. And so I cannot even describe to you guys how long it used to take me to do this kind of design in AutoCAD. Emily, you're muted, but you're very excited, right?
I wasn't even saying anything. I knew what you were going to say. Yeah.
But how long it took me to design this in AutoCAD, and also how long it took me to design it in Revit without environment tools. It was like 10 minutes what I did over here, right? And that's like a great starting point. So the more you master the tools, the more you can get good results very fast. And Emily, I know your partner is just learning landscape architecture and you're kind of into it and you know what it takes to just really design a path and comply with standards and regulations. And it takes so much math, right? Instead of being very intuitive, very 3D viewing with Revit and environment for Revit. So I think that's a great workflow to finish with for today, right?
I think so. And for everybody out there who wants more information on Revit, because I think that's a big part of this, is there's a lot of people out there who don't even know enough about Revit to understand what environment brings to the table on top of Revit. So Revit has fantastic modeling capabilities in all senses, and then environment for Revit brings specific landscape workflows to the table that Revit doesn't have, or that if you were to do in standard Revit, there would not be enough detail in the thing you're trying to do, or the tools in Revit to do what you want to do with efficiency. So what environment does is it lays on, it bundles the workflow into one of the tools so that you don't have to go through and manually update every point like you would have if just Revit was involved. So it really is just sort of an above and beyond tool to help your Revit workflow, and help you make it through the day. So we've got 5 minutes left. I have one question that has come up a few times, and it's probably a huge question, but to touch on. The effectiveness for using Revit and environment for larger scale or master planning projects, and I'm just going to say one thing before maybe Nehama or did. There are other tools in the Autodesk environment, such as one that I am just completely forgetting. I'll find the name of it. That may help on the larger scale of things. There's Forma for early phase planning, and InfraWorks for master planning and dealing with infrastructure. And Revit is just going to be a part of that. When you're dealing with such a large scale scenario, Revit is one part of it. Anything to add to that?
No, I think it was a good answer. You should be really mindful because just saying large scale projects, it means something different to everyone else, everyone. And, master planning can be very detailed. So whenever you want to be very detailed with your design and understand and be very accurate with the elevation and material of every element, that's where Revit goes into the picture. But when you want to examine the bigger picture, I agree with you that the Autodesk ecosystem just provides you so many tools. Like, I think just Google Autodesk Forma, and this tool is just starting up, but it gives you so many different analysis information and just like quick SketchUp like tools to just start your design. And they all integrate amazingly into Revit. So you can build your workflow according to your needs. And by the way, environment is gonna have a cut and fill calculation, an estimate tool for Forma very soon. So you'll be able to take very large site and just roughly modify the terrain and get the estimate before even you start to design the site. And that's all included in the Autodesk suite in the collection. So yeah, I think it just people like Emily and GRAITEC are here to help you understand what exactly is the workflow that's relevant for every project that I'm doing.
And the tools that are available to you, because a lot of people think, oh God, I have to buy another tool. But in a lot of cases, if you're working in AutoCAD already and you might need Revit as well, there's a tool package called the AEC collection. And that's going to come with Forma. It's going to come with Revit and AutoCAD, a number of cloud tools at some of the entry-level elements. And so you can jump right in there and have access to a lot of data, including something called Twinmotion, which is a fantastic rendering software. So for those of you asking about visualization and getting in your landscaping elements like trees and so on, Twinmotion, fantastic. And it comes with that AEC collection. So there's a big package out there available for you to start from.
Nice.
Misty?
Y'all saw my head pop up there. You're like, oh, she must be doing the timer. We are rounding up at the hour here, so I wanted to thank you all for bringing such value to today's office hours. I want to thank everybody else for attending as well. This has truly been such an amazing series, and we really, really love being able to bring these answers to your questions. So as we wrap up, I want to let you know you will get a recording to this webinar within 24 hours. You will get to be asked a question, your gift card within 48 hours, and then give us some time, and we are going to put together all of these wonderful questions and post a FAQ for you guys to get additional information as well. But I want to thank you all, and we hope to look to see you on future webinar and office hours.
Thank you.
Thanks, everyone.